we've got an M-class solar flare right as we record the video. From that location right there, one of these sunspots right in the Earth-facing zone. And welcome to the Daily Space Weather. A regular feature here at the Smash News Network, Least Busted, Name and News. Let's get to some more footage here, as we've got plenty of it today. Here's some composite imagery from the SDO. This is 304 and 171 angstroms. Again, we've got a large solar flare happening here in the M-class range as we record the video. We'll be watching for a coronal mass ejection generated by that flare or associated with that flare. Here's the northern hemisphere in these wavelengths. Here's 1600 and 1700 angstroms. Again, we've got at least 7 named sunspot groups at the moment. And again, that flare came out of this area right here, right around there. And here it is back to 171 and 304 angstroms. Spectacular imagery there from the Solar Dynamics Observatory. We've got a cosmology segment to integrate into this daily space weather video as well. We'll get to it momentarily. First, the colorized magnetogram to show all that magnetic organization happening, primarily in the southern hemisphere, but some sunspots in the north as well. Here's the full disk view. This is 1600 and 1700 angstroms. The 1600 angstroms does show ionized carbon. We won't worry about it at the moment. Let's blast through some more stuff. The radio flux has leveled off here. I think it's down to 115 now, having made it up to 121. That is the most proportional data set to sunspot number that we have. So this black line here, this is the 1-year graph of the radio flux. And you can see as it's increasing here with the progression of solar cycle 25, the red line below it is the sunspot number. The blue line is the AP index, a measurement of the interplanetary magnetic field. And let's head to the Space Weather Enthusiast dashboard here. We did see a brief period of geomagnetic storm last night. It was caused by the shock front of a coronal hole wind stream, which we're now seeing an elevated solar wind as a result of that. We'll get to that in a moment. First, seismicity. The largest quake of the past 24 was this 6.3 north of Fiji, a 6.3 magnitude quake there. Also, volcanic uptick at Tonga. We'll get to that shortly. And there's the location of that 6.3 magnitude. There was also a 6 magnitude at the South Sandwich Islands region. And let's scroll up the list. That 6.3 near Fiji occurred at 1628 Universal Time yesterday on 12/19, December 19th at 1628 Universal Time. Laos saw a 5.6. Papua New Guinea saw a deep quake at a 5.3 magnitude. That was over 230 kilometers estimated depth. South Sandwich Islands, second largest quake there, a 6.0 magnitude. So it's a bit of a seismic uptick here, folks. Keep in mind, any earthquake could be a foreshock. Continuing up the list, a bunch of quakes in Alaska, as well as some minor shaking in Texas and Hawaii. If we've missed anything on the list, leave us a comment. We consider these videos a collaborative effort. We cover a lot of data, so you don't have to. Next, volcanic rundown here. Suwanosei-jima continues to explode, producing a 9,000-foot plume of volcanic ash. Please don't pole vault the caldera. And Hunga Tonga Hunga Ha'apai has been producing plumes of smoke and steam. So perhaps a significant eruption preparing to happen there at Hunga Tonga Hunga Ha'apai on the Tongan Islands. Samisa-Pochnoi volcanic ash not detected in that Aleutian volcano. Fuego exploding, 15,000-foot ash plume over Guatemala from Fuego. Nevado del Ruiz, 21,000-foot ash plume over Nevado del Ruiz as it explodes. That's located in Colombia. Revenador exploding, 15,000-foot ash plume over Ecuador. and continuous ash emissions of an unknown size over Peru, resulting from the eruption of Sabancaya. Today's featured product is MANSA, Make America Not Suck Again. Since America largely leads the way, we need covidiocy to be cured in the U.S. before anybody else expects to cure covidiocy, so we can't wait until that happens. Getting a little bit anxious. Are you finding yourself a little bit anxious, folks? Well, we would invite you all to MANSA, Make America Not Suck Again, since it's up to you, not ineffective bureaucrats who can't even get out of their own way. America leads the way in so many things. Let's lead the way in curing covidiocy. Yes, the pathetic and infantile response to the coronavirus, the mysterious disappearance of the flu, and so forth. All of this stuff needs to be fixed, and America needs to not suck again. Who's responsible for making it not suck? Tell your friends and foes, pick up some merch, support the channel, or become a member of the SMASH team, perhaps. We forecasted the reduction of the geomagnetic storm conditions. SMASHOMASH.com/SMASH team. We've replaced Patreon. Welcome to the Neo Renaissance. Visit our links. Support the channel if you'd like to see the videos continue to exist and remain publicly visible and free for all to view. Thanks to everybody who has been supporting the channel. Let's get into magnetic data. Here's the GOES magnetometer graph from the GOES 16 and GOES 17 geosynchronous orbital measurements over the past 3 days. And you can see this little spike happening here, this sudden reduction in magnetic flux density there, measured in nanotesla. Also an arc jet moment there. That is when the GOES, what is that? The GOES 16 turns on its thrusters, creating plasma which could affect the magnetometer measurements. Next, the heliospheric current sheet. By the way, this data is from 51 ground-based magnetometers, as well as magnetometers on stereo A at Lagrange 5 and stereo B at Lagrange 4. There is a North Pole current sheet headed Earth's way, as we forecasted a few days ago. And there's a magnetic tug-of-war happening on the eastern limb of the Sun as cycle 25 progresses. So here's the line-of-sight view of that same data, essentially, the solar magnetogram also on there. Most importantly, here's the line-of-sight coronal hole plot. This is the best piece of data to watch the progression of the solar cycle. So as you see, you can see the North Pole coronal holes here shown in green making their way across the equator. South Pole coronal holes doing the same. That is the progression of the solar polar field reversal, which is what the solar cycles are. And the migration of those coronal hole magnetic fields are just as important as sunspots. That's magnetohydrodynamics, the line-of-sight coronal hole plot. It also shows you the sun's B field in blue. Here's a visual in 193 angstroms from the Solar Dynamics Observatory. Again, getting some high-speed wind from coronal hole systems at the moment. We'll get to it in a minute. First, the detected sunspot groups, and we're showing at least 7. It looks like for a moment they're showing up as 9 sunspot groups, but in any case, at least 7 sunspot groups. We won't rattle off the names. The likelihood of additional large flares is certainly high. Again, there was an M-class flare happening as we recorded the show. So there you can see that M-class flare. Looks like it leveled off. Not going into an X-class flare yet. Don't be surprised to see an X-class flare with the amount of magnetic organization we have. Here's a 7-day chart to include the last M-class flare, which happened early in the morning on the 17th. Once again, there's the 3-day. And how about the 6-hour? There you can see the peak flux of that M-class flare was right around 11:30 Universal Time. And let's continue on. No spikes in the proton flux yet. There could be relativistic particles headed our way from that M-class flare. It's pretty likely, actually. So don't be surprised to see a spike in the proton flux and polar radio blackouts as a result. I'm sure we've already seen some radio blackouts. Let's check. And indeed, there you can see the deabsorption prediction. That M-class flare happening around noon local time for southwestern Africa. Where the ionosphere gets affected by the incoming X-rays, preventing high-frequency radio transmissions from refracting on the ionosphere. Next, the real-time solar wind. And the geomagnetic unrest we saw last night was the shock front and the very high magnetic field. Check it out. The BT was all the way up to 24 and the BZ at -19. That's what spawned the short-lived geomagnetic unrest and geomagnetic storm we saw last night. A BT of 24 and a BZ of -19 is a very strong BZ component, which lends to induced currents in Earth's geospace. Since then, we've seen the density subside and the velocity come up. So we're seeing quite a fast, high-speed coronal hole wind stream here, 542 kilometers per second, with a density of just under 10 protons per cubic centimeter. Coronal hole wind stream all day is what that signature tells us. So here you can see the KP index over the past 3 days. And indeed, we're back to geomagnetic calm conditions. A KP of 2, having reached all the way up to a KP 5, a brief geomagnetic storm. I think communications errors are shutting down the geospace magnetosphere movies. We've got massive chaos in the electron flux. We'll get to that in a moment. The most chaotic electron flux, total electron content that we've ever shown on the channel. Expect massive GPS errors over places like North America. We'll get to it. First, a forecast of what's going on in the solar system. And again, let me reiterate, folks, please don't be frightened of planets. They've been there a long time, a lot longer than you have. And the idea that planets orienting themselves near each other from your perspective in the sky isn't any sort of a harbinger of anything, certainly not of doom. Here's where stuff's located now. Tomorrow is the winter solstice, or if you're in the southern hemisphere, the summer solstice. We'll get to a countdown to that momentarily. First, the forecast. And there's where things will be in a week. Mercury catching up to Venus as Venus makes a close pass between Earth and Sun. Next, the astronomy picture of the day today. It's Comet Leonard and a small meteor. Now, Comet Leonard's nucleus is believed to be producing that green tone as a result of carbon. This meteor believed to produce that as a result of magnesium evaporating in Earth's atmosphere. That's the astronomy picture of the day at apod.nasa.gov. It's a pretty good desktop if you'd like to go check it out yourself. Again, the URL is apod.nasa.gov. Shout out to Corey Poole. So yeah, the comet is believed to be producing that green tone as a result of diatomic carbon, and the meteor produced it because of magnesium. Great astronomy picture of the day as Comet Leonard moves out of visible range and into the southern hemisphere skies. Speaking of skies, here's a star chart. We've drawn in the ecliptic, which is the sun, the path the sun will take across the sky, as well as the blue line down here. That's the galactic plane. And let's take a look at the coronal mass ejection situation. We are expecting one as a result of that M-class solar flare right in front of Earth. Here's the most current image we could figure from the LASCO C2, and we are seeing a CME looking like it's kind of headed off to the southeast. A little bit of old data there. We may have to make another video today. Let's do a brief cosmology segment. This one's integrated to the Daily Space Weather video. We've got hundreds more in our playlist at youtube.com/smashamash/playlists. Today's quote random end quote number is 681, which is a low mass X-ray binary known as SLX 1735-269. Again, it's number 681 at the Neil Gehrels Swift-Bat X-ray Observatory transients page, which looks a lot like this. And it looks like it's winked out here. So it stopped producing X-rays over the past about 3 weeks. That's the 30-day chart of its X-ray production. Interestingly, there is a recent article here, only about a year old, about a new AI machine learning approach for classifying low-mass X-ray binaries based on their compact object nature. So these tend to be a more normal star being orbited by a more compact, weirder object, a thing like a, quote, black hole, end quote, or a neutron star, or some sort of other more compact object. And so this is an interesting paper here, as its AI is objective in its analysis. So perhaps have a read on that. You can find a link to it by going to the transients page. If you click on SIMBAD, that'll link you to the CDS portal, which looks like this. There are the photometric points for this low-mass X-ray binary. You can see it's quite bright, sort of in the middle of the electromagnetic spectrum. And it didn't really get studied very much until after 1990. Quite a bit of papers on that low-mass X-ray binary. And let's take a look at it visually here. Here's the 70-month X-ray survey. That is the Swift-Bat, I believe. That's the Swift-Bat 70-month X-ray survey. You can see it's in a pretty busy part of space there, around a bunch of other significant X-ray sources. Let's take a look at it higher resolution here on the Chandra. See if we can resolve that. There is a higher resolution image of that low-mass X-ray binary. That is also in X-ray. Let's take a look at some other wavelengths. And if we look at this in ultraviolet light, this is the Galix. You'll see no signal there whatsoever in ultraviolet. How about in optical light? Here's the Pan-STARRS. And it's showing up pretty dark there in optical as well. Does it show up in infrared? I have a feeling it doesn't. Let's take a look. It's just a very busy part of space, and it's actually kind of dim there in infrared. Anyway, going back to X-ray, here's the ASCA public data image. You can see it is indeed quite a bright X-ray source. That low-mass X-ray binary, again known as SLX 1735-269, entry number 681 at the Neil Gehrels Swift-Bat X-ray Observatory. Today's, quote, random and, quote, cosmological object. That's today's cosmology segment. Again, don't forget to check our playlists. Over 200 additional videos about cosmology at youtube.com/smashomash/playlists. Now, we do see some charging hazards here for the surfaces of geosynchronous satellites. Geosynchronous equatorial satellites, seeing some surface charging hazards here around the Central Pacific, and they've just increased. So charging hazards there over Mexico there as well, and the Central Pacific. Here's the electron flux over the past 1 year, and we're probably moving into electron flux warning levels here. So we're going to see massive GPS errors around the world, including over North America. Make sure you have your Wi-Fi location accuracy turned on. If you want accurate GPS readings, we're going to see huge errors today. In fact, maybe we'll even make a video about that. Anyway, that's the electron flux over the past 3 days. We're expecting an uptick here. So there's the NOAA forecast. Only forecasting a small uptick here. And, well, we'll have to just keep an eye on that. I won't argue with the NOAA forecast today. I'll just show you the total electron content forecast, which is pure chaos. So look at the massive GPS errors expected over North America and so forth today. Also, the Southern Ocean expecting some GPS errors in the middle of the night. This is, I think this is the most chaos we've ever shown. And we do show the total electron content forecast daily, as it's going to show you the most likely spots for GPS errors. It's quite useful for all of you travelers out there. So huge GPS errors expected over the West Pacific. I'll let it play through one more time. Look at the massive errors expected over North America here. And this probably has to do with why the geospace magnetosphere movies aren't playing. There's a little bit too much chaos for the models to be legit. Let's take a look at the ionosphere next. Located at about 300 kilometers of altitude, the F layer is what we're now showing in vibrational frequency here. Each color blob represents 1 megahertz. That's millions of vibrations per second. And unsurprisingly, we're seeing some significant anomalies here as well. We'll also show you the anomalygram. Once that plays through, here's the anomalygram showing anomaly in megahertz from the 30-day median. You can see once again anomalies centered around the Drake Passage, one of the weirdest parts of the planet. The planet where the Atlantic and Pacific Ocean try to reach static equilibrium. How many trillions of gallons of water must be rushing back and forth through the Drake Passage in order to reach static equilibrium? Enough that it never does reach static equilibrium, I'm sure. Anyway, there's the latest image. That's 12 o'clock Universal Time ionogram, 12 o'clock Universal Time anomalygram. You can see low-frequency anomalies there moving over the south portion of Africa. It's time for bonus features. Bonus feature number 1 is the ground-based solar observatory at Cerro Tololo, Chile. Again, M-class solar flare having occurred right around there while we recorded the video. Again, we may have to make another video today as a result of that. Here it is on the GOES 16 SUVI. It's where we started the video. You see that little intensification right there. It might not look that bright. These things are better framed against the limb of the sun. Let's take a look at the colorized magnetogram and the intensitygram real quick. There's where the solar flare came from. Here are a bunch of quite active sunspots here. They've largely remained stable since yesterday. Quite a lot of sunspots here in the hundreds. Here are the magnetic fields. Let's do another little trip here around the magnetic field environment. Many beta-class sunspots. Too many to comment on individually. I was going to say that the most likely spot to see a major flare would be out of exactly where it came from, right out of that area. But I guess I don't have to do that because it beat me to it. So we'll close out today's video with some composite imagery. 131 and 94 angstroms are the highest temporal resolution that the SDO takes. The SDO in these wavelengths takes 10 images per minute instead of only 2. They're specifically for observing solar flares. We'll close out here. Thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back. Opinions expressed in this video not necessarily the opinions of Smash News Network, Least Busted, Name and News.